Hey there, wanted to share with you how I built and structure my SaaS applications by having a solid architecture from day zero. Today we're going to explore something really important, how taking a disciplined approach to your workspace, dependencies, and boundaries can make all the difference when you're building complex applications. Throughout this presentation, I'll walk you through the architectural principles that keep modern VS Code extensions stable and scalable no matter how much they grow. So, here's the thing about modern VS Code extensions. They're actually two applications rolled into one. You've got the extension host and the web view working together. When you're building an extension, you're really juggling multiple execution contexts, dealing with complex service lifecycles, and managing real-time communication between a back-end host process and a front-end web view. And let me tell you, without the right architecture in place, this complexity can quickly spiral into chaos and instability. Now, our solution to taming all this complexity, it rests on three fundamental pillars of architectural stability. Let me break them down for you. First up, we have the workspace, which gives us a unified monorepo for structure and builds. Second, there's the dependencies, a predictable system that handles service orchestration. And third, we've got the boundaries, which enforces a strict architecture for dependency flow. These three pillars don't work in isolation. They work together beautifully to create a system that's both maintainable and scalable. All right, let's dive into pillar one, the workspace as your single source of truth. Take a look at this comparison. On one side, you've got multiple repositories, features, or domains with their tangled dependencies and version conflicts. It's a mess, right? On the other side, there's an NX monorepo with its clean hierarchical structure. The difference is night and day. The monorepo approach eliminates code duplication and add proper boundaries between features. Also eliminate these frustrating version conflicts. It lets you make atomic changes across projects, and it gives you a solid foundation for a clear domain-based structure. This unified approach, it's absolutely essential for managing complexity. Now, within our workspace, we do something that might seem over-engineering at first. We organize code around business domains, not technical layers. Check out this directory structure. You'll see libs, users as a domain or a scope containing users front end, users back end, and users API all together. Why do we do this? Well, it gives us three key advantages. First, there's business alignment, where your code structure actually reflects your business capabilities. Second, you get team ownership, so teams can own entire vertical domains from top to bottom. And third, you have clear boundaries with explicit context boundaries between domains. This domain-driven structure makes your code base so much more intuitive and maintainable. Here's where things get really cool. Our workspace enables intelligent builds that maximize performance. The build system is smart. It only builds what's actually been affected, and it does it in the correct order. Two key features drive this performance. First, there's intelligent caching, which means we only rebuild what's changed, dramatically accelerating build times. Then we have parallel execution, which runs independent tasks simultaneously to squeeze every bit of performance out of your resources. Put these together and you're looking at dramatically reduced build times. Okay, now let's move on to pillar two, the dependencies management and how we decouple them using something called inversion of control. For most of the time, your framework will have something like that already entangled like Angular or Nest.js. But in our case, we had to utilize a TypeScript library for crafting that. Once you take a look at this slide, it contrasts code before and after dependency injection. Before DI, classes are creating their own dependencies, which leads to tight coupling. Everything's connected to everything else. But with DI, a central container provides dependencies through constructor injection. So instead of classes creating their own dependencies, a central container handles it for them. This simple shift makes your code more modular, more flexible, and way easier to test. The centralized container uses something we call phased service registration to manage all this complexity. Let me walk you through the phases. Phase 0 is the extension context. This has to come first because it's the absolute foundation of everything. Then phase 1 registers your infrastructure services, things like logger, error handler, and config manager. Phase 2 handles your domain services, including workspace intelligence and context orchestration, which contain your core business logic. Phase 2.7 covers the agent SDK. And finally, Phase 3 registers your app services like Web View Provider for UI providers and commands. This phased approach ensures that services are always registered in the correct order with all their proper dependencies in place. Now we come to Pillar 3, which focuses on the boundaries through a strictly layered architecture. Take a look at this diagram. It shows 6 layers stacked from top to bottom: applications layer, front-end feature libraries, front-end core, back-end domain libraries, infrastructure layer, and foundation layer. Here's the critical rule you need to remember. Dependencies must only point downwards. Lower layers must never ever know about higher layers. This isn't just a suggestion. It's what ensures you have a clean, maintainable architecture that won't collapse under its own weight. Now here's the really cool part. These architectural boundaries, they're not just suggestions we hope developers follow. They're actually enforced automatically in our codebase using linting and tags. So let me show you what I mean. The applications layer can depend downward on the infrastructure layer. That's perfectly fine, right? But if the infrastructure layer tries to depend upward on the applications layer, it gets blocked. The system won't let it happen. This automated enforcement catches architectural violations before they ever make it to production, which is exactly what we want. Alright, let's bring this all together with a real example. I want to walk you through what actually happens when a user interacts with our extension. So imagine a user clicks send in the front-end chat. That click triggers an RPC call which invokes our backend. Then the domain logic kicks in at the agent SDK layer where it performs all the necessary transformations. Meanwhile, our infrastructure logging layer is capturing everything that's happening. Finally, the response flows back up through all those layers and gets displayed to the user. Pretty elegant, right? This is our 3 pillars in action: workspace organization, dependency injection, and strict boundaries all working together seamlessly. So what do we actually get from implementing these 3 pillars? Well, we end up with a system that's both maintainable and scalable, and that gives us 3 huge benefits. First up is efficient code sharing. With NX, our front end and back end can share a single source of truth for types and contracts. No more duplication, which is fantastic. Second, we get high confidence testability. Thanks to our dependency injection, we can replace any service with a mock. That means true unit testing becomes possible. And third, we enable parallel team development. Because of our strict layering, different teams can work independently without stepping on each other's toes. This architecture really does support growth and collaboration at scale. Let me wrap this up with the key lessons we've learned from building this architecture. First, centralize your contracts. Define your shared interfaces and models in one accessible place. Trust me, this keeps everything consistent. Second, respect those layer boundaries. Enforce a strict unidirectional dependency flow and stick to it. And third, keep your foundation pure. That lowest level shared library should have 0 external dependencies. It's the bedrock of your entire application. When you bring all these principles together, you create a stable, scalable architecture that can grow right alongside your needs.